All right, who's interested in getting one into a pilot? All right, a few hands. Very cool. So we will go ahead and actually get started. And one of the first things I wanted to do was just talk about, kind of right out of the gate, what use cases your organizations might be using with generative AI today.
So what happens is, this is what Lenovo did for us, right? So they did a replication when we moved to SQL. And so we're able to create table views specific to the use cases that we're trying to build those AI agents, right? So it basically tells you like the summary of bill of materials that we're using, and it will tell you the differences. So two things that we found value in AI, right? It's either you're enhancing your business process and you're trying to gain improvements, right? So getting that information as quick as possible, or information to gain your market share, right? So like this one, when we try to use ChatGPT about our products where we can improve, and then we have a ChatGPT here for some of our marketing campaigns and compare the different campaigns that we have for different countries.
Okay, but you're running it. What it looked like you were running through to do? Did it just look that way when I glanced up? Or?
So you can use it as like a chat, like you're chatting with one of your team members.
It exposes it back into Teams. So
That's
now,
fantastic.
so now this AI agent is just someone you talk to in Teams.
But that was built through Copilot.
Yes.
You created it in Copilot Studio, right?
Yes.
Yep. How did it connect to your data?
So we have a data warehouse that
Okay.
Lenovo helped us replicate it into our data warehouse, and we create views for
Yep.
certain use cases.
Yep. Okay.
And then so natural language, we just train it to run the SQL for you.
Sure. Okay.
All right. Hey, so Sampath, you had mentioned you all had a use case.
Yeah, we have something similar. We've connected Copilot Studio to SharePoint that contains all our transformations. So the DSRs can query upon those order confirmations. And we use it for data extraction from the PDF.
Some pretty cool stuff. So kind of jumping into the agenda. So a couple things. We talked about customer use cases. Very briefly, we're just going to talk about what Gen AI is. Just highlights for like the two people here that might not know the answer to that. We'll talk about when generative AI is a useful tool, when it's the right tool for the job, but more importantly, when it's not the right tool for the job. A lot of what we see today are basically people have got this solution that they're running around looking for a problem, trying to solve, versus approaching it the other way. And then we'll explore some of the JDE Edwards related use cases, and then wrapping things up. So what is Gen AI? So I am assuming, is anyone here not used ChatGPT, Gemini, or something similar? Okay, awesome. So at the end of the day, all large language models are fundamentally like the keyboard on your iPhone or Android. And it's literally doing next word prediction on steroids. And so it's basically gobbled up the entire internet. It's trying to form relationships between them. If I take this word and the next word and the next word, the more words I've got, the more likely I'm able to predict what's next. And I don't know about you and your phone, but it's pretty uncanny. It's like mine knows exactly what it is I want to say, and I'm just next, and it's filling it in. So a token is kind of the fundamental unit for a large language model. So all of these are examples of tokens. But so is this in brackets. So every word that exists out there is not a token. Interestingly enough, common words or common phrases are also a token, like thank you is a token. It just, as far as the large language model is concerned, this is one logical unit together. It places it somewhere out in vector space. And then all of this fits within a context window. And depending on what models that you're running, the context windows can be really, really tiny, or they can be super large. Typically, the larger the context window is, the more expensive the model is to run. So really, it's context window size and the number of parameters that the model is coming drives both cost as well as accuracy, the quality of the results that you're getting. So you've got this constant trade-off between model size, quality, and cost that you're trying to balance if you're going kind of this agentic large language model route. A couple things. This is actually a fun one. So this is kind of illustrating model size, parameter count, and why this is so important, and some of the shortcomings of these large language models. So I want everyone to take a minute, read over this problem, and give me an answer. So we'll take a minute, let everyone read over this. All right, has everyone reviewed it? All right, how many vote for answer A? Show of hands. No takers on A? What about answer B? I'm sorry to report the answer is A. So this is something in behavioral economics that is known as the conjunction fallacy. So when you think about it for a minute, so this right here, answer B, is a subset of this. So this can never be more likely than the one above it. So descriptively, it's like, yeah, that looks like a much better match. But really, the answer is A. So when I went through, and this was an exercise I ran through last year with several of the large language models, giving it, this is actually in behavioral economics, this is referred to as the Linda problem. I had to rewrite the problem, otherwise it knew what the answer was just because it was in a book somewhere. It was already part of its training data. So I went through and I scored all the models. So the last column there, this is parameter count. So 7 billion parameters, 8 billion parameters, 70 billion parameters, and basically scoring it. So I gave it an A if it got the answer just right off the bat. I gave it a C if after it gave me the wrong answer, I could say, consider the conjunction fallacy and let me know if you want to revise your answer. And about half of them, when I gave it that, came back with something like this. It's like, oh, yeah, you're right. That's wrong. This is actually the right answer, and this is why. And the thing I loved with the Mistral model is it actually came back with like the mathematical formula explaining why it was wrong in the first place. And then some of the smaller models, they just literally doubled down on, no, I'm right, you're wrong. So the reason I bring this up is because a lot of the use cases that people are trying to do with JD Edwards today are complex scenarios like this, where you've really got to be suspicious about the answers that it's coming back with, the quality of the results. Is anyone familiar with the strawberry problem? So OpenAI actually last year had an entire endeavor. They called it Project Strawberry. And what it was about was early on when ChatGPT 3 and 4 first came out, you would ask it, how many R's are there in strawberry? And it would come back with a different answer every time. It would spell the word strawberry correctly, and then it would tell you the wrong number of R's. And this is what people often are trying to rely on to make quantitative decisions. Something that actually wasn't even able to count the correct letters of in a word. Now, I will tell you, in the last 12 months, on the quantitative side, it's still not going to be the right answer for most of you. Tremendous progress has been made. Basically, spending close to like $500 billion. OpenAI can now count the right number of R's in the word. So, how many of you saw this? This came out three to 4 weeks ago. This was a study from MIT where they were going through and they were doing a survey of publicly traded companies that had publicly disclosed generative AI projects that they were introducing to their organization. 95% of those failed to demonstrate any massive gains in productivity or any improvement to the bottom line. And I mean, that's really a stark statistic that really kind of set the whole AI community on fire, trying to determine, okay, why is this? I mean, this technology is like literally magic. If anyone has, if anyone's interacted with it, you know there are moments when you're using it where you're like, oh wow, I would have never thought of that. I would have never gone there. It gives you like this area of investigation that you never pursued before. But 95% of companies are realizing no material benefit for it. And this is kind of why, how many of you are familiar with the Gartner hype cycle? So new technology comes out, everybody gets really excited about it. And this is where you've got the inflated expectations. So these inflated expectations typically happen at a board level of a company. They've been reading the literature, they've been hearing about what other companies are doing, and they feel like they're getting left behind. FOMO, if you all are familiar with that term, fear of missing out. So everybody wants to do this generative AI project. They want to. How are we using it in the organization? So that goes to the company's executives. That goes to the senior leadership team. That makes it down to the director level. And all they know is we've got to come back with this use case that is using generative AI somewhere in our organization, because it's a corporate priority. Well, it doesn't deliver the value. This is where you end up in the trial of disillusionment. And I would say that right now this is largely where we're at. Now, the good news is we go up from here. And if any of you all have worked with this, I mean, this stuff is magic. This stuff is the future. Everything that the board thinks it can do, it probably will in about 3 years. It's just not totally there yet. So the way I think about it, when to use Gen AI, when not to, is really I break it into kind of 3 different classes of problems. You've got quantitative problems. These are typically numerical and structured data. You've got qualitative problems, which are messy and unstructured. And then you've got software engineering, which is almost its own thing. And literally, if there's one thing that generative AI has literally solved at this moment, it's that last category, software engineering. There was never a worse time in history to be an entry-level software engineer. because this is basically the equivalent of right now somebody with about 4 or 5 years work experience that you're getting out of the box. So quantitative, it's numbers. It's numbers in, numbers out. Your messy, unstructured data. So this is like where I've got these PDFs out here, and I want you to analyze it, and I need you to fit this into one of 4 buckets. And this is going to be using human level kind of heuristics, going about trying to solve the problem. Now, the important thing to know about this is it's going to probably be wrong about as frequently as the human was wrong when they were going through looking at it. So you do not have programmatic certainty with these models. They're probabilistic in nature. And software engineering, we really don't need that guy anymore. So use case. So one of the things I use this for constantly is with ChatGPT. It's got a feature called Codex. Is anyone here a programmer? So who am I slamming on with the software engineering? Yeah, but you're like the senior one that don't have to worry about it. So Codex, I linked this to my GitHub repo. So it's got the entire context of my entire repository in GitHub. And literally, I describe what code changes I want to make here. And it goes through, it makes the code changes, creates the pull request. Go in, review the pull requests. If I have it configured properly, which at the moment I don't, it runs through all the test cases that are pre-configured. And basically all of this is just literally, it's writing the code for me. So probably about 80% of the code I have now in the repos I manage, generative AI is creating. I'm curating it. I'm fixing and dealing with edge cases, basically. The other thing is, I would say probably within the last 12 months, I've done what would have previously taken me 10 to 15 years in terms of the amount of code that has been generated. So it is just an unbelievable exponential gain that I'm picking up. This is just a view from kind of GitHub. All of the commits it made. I think literally it did like 9 commits this weekend as I was working on stuff. So that was some internal stuff that I was using, kind of internal de novo management. But you all are here to talk about JD Edwards. So who here has a customized JD Edwards environment? Who are the evil people that have modified core code? Yes, I see all of you. So I used to joke that the first thing I would do when I would meet with a prospective customer, I'm like, did you all modify sales order entry? And if the answer was yes, hey, have a wonderful life. And turn around and walk off. But the bottom line is, a lot of times the reason that you're modifying the system is because you have a business process, you have something unique in a business process that gives your organization a competitive advantage. And it's worth all of the pain that you're causing downstream. And there is a lot of pain involved in modifying JD Edwards code. But the advantage that you're getting from modifying it is hopefully worth all of that pain. The good news is a lot of that pain can go away. So using the example of retrofitting a master business function. This is something we do all the time internally. So take so first of all, who has a problem with developers not maintaining good documentations or not having good specifications on what was done? It's everywhere. It's chronic. I hate to say it's us. It's pretty much universal around. Not as big of a deal as it used to be. So we take the original unmodified code, we take the modified version of the code, and then we ask ChatGPT to create a detailed specification off of that. What is the delta? And then based on that, also things like what are the test cases for this to ensure that this is working. So it creates this detailed specification. So now you've just applied update 9, and your 4,000 lines of C code just got whacked. Whacked is the very technical term for what happens when it gets overwritten. So now you take that new business function that does not have any of your code, you take that specification that was just created, and you ask it, modify the code based on this specification. So something that could have been weeks or months, depending on complexity, is now about a 30-minute operation. I mean, this is huge in terms of organizations' ability to avoid technical debt. One of the main reasons organizations don't upgrade JDE Edwards, don't stay code current, is just the pain that's involved with having to continually go through and do those retrofits. Now, not specific to Gen AI, but I will throw out, always before you go and do that, go back and evaluate, is this change still needed? Because a lot of times these changes will have originated like back in the XE days. And since then, it was use cases that JDE Edwards didn't support at the time, but maybe 10 years ago they started supporting it, and you no longer actually still need that retrofitted code. Anyone use it for Orchestrator? This is a really, really cool use case. You can literally describe how you want your orchestration to work, what you want it to do, and have it go out and create it for you and import. So we talked about kind of the 3 types of problems. So quantitative, qualitative software engineering. We just kind of double clicked on the software engineering. Let's talk about quantitative for a second. So kind of this is numbers in, numbers out. And this is where I think a lot of organizations are not finding the value from the solution. And I'll use a real world example here. So this is one of our customers. It's a construction company, has built a solution to predict where they're going to be on with cash, 2 weeks, 3 weeks, 4 weeks from now. Because they're a very cash intensive org, and they really don't want to tap their credit lines. They'd like to be able to flow all of this. So they basically take all that historical data from customers. Do they tend to be late paying us? What is the AR outstanding? All of this, and they have a model that gets about a 91% accuracy on forecasting. So this would be an example where you would not want to use a large language model or generative AI. You could probably make something work. Your accuracy is not going to be that 91%, and it's going to be way, way, way more expensive than using traditional analytics. Which, by the way, this has AI in it as well. This is just more of the old school, traditional machine learning approach. So these are just, and I won't go over all of these in details, but this is a bunch of other quantitative problems that I've seen organizations try solving with large language models. But what about chatbots? So the use case that Angelo showed, that was actually pretty cool. That was some good data. Generally though, on chatbots, I'm not overly excited. And there's kind of really 2 scenarios. There's how do I, and how do I is like really useful. So you build something with all your internal process documentation, and a user needs help getting through a process. That's a great use case. Using it operationally though, to what is the status of order 5, 6, 7, 8, 9 for customer number such and such, or is product number, whatever that product number is, on back order. These are all things that you can make work, but it's all very memory intensive. And so with JD Edwards, you've got this beautiful, rich UI, and now you're replacing it with something that people have to remember, these long strings of numbers. It's sort of like Alexa. Does anyone remember 6, 7 years ago when every other session at INFOCUS was how to integrate JD Edwards with Alexa? None of the, and it was cool, it was exciting. I went to half of those sessions. I was geeking out on it. But the bottom line is none of that actually drove real business value. None of those really made it into production use cases. And that's largely where I think the chatbot arena with JD Edwards is. Okay, so let's talk about the qualitative side. So who here today is doing anything with like AP automation or other things where you're ingesting data, you're ingesting documents, you're stripping out the data and somehow you're getting it into JD Edwards? Can I have a show of hands? So any bottom line, anyone? Bottom line? Yeah, but bottom line was like the kind of the gold standard for years on doing this. So what's interesting is document understanding really can fall on the qualitative side, which I'll talk about in a minute, or the quantitative side. So when I'm thinking about quantitative, if it's structured data, we're dealing with something quantitative in nature. So if you have to go through and as part of your document understanding, you're doing data labeling. The data labeling is making it a quantitative problem. So if you're doing document labeling, so you take the document and you're actually telling it this field means this field means that, you're turning it into a quantitative problem. And this is how a lot of the traditional products work. Everything from bottom line to Oracle's document understanding is all based around that data labeling. But what if you don't want to do that? What if you just want to tell the language model, go figure it out? So that's what we did here. So what I'm showing on the screen, these are actually some receipts from a home remodel project that I was doing. So all of these are different document types. Lowe's receipt. I should just have my paycheck direct deposited with Lowe's. It would make things easier. And then a handwritten receipt from my termite control company. So I take those. And by the way, I'm showing here, I'm uploading them into object storage. Within the last 2 months, I no longer need to do that. I can now ingest them directly through the API. And then I'm feeding them into ChatGPT. And then I'm getting ChatGPT to return back to me structured JSON. Structured JSON, I guess that's kind of redundant. This is kind of an example of what it is. So I tell the model, this is what I want my JSON to look like. So you know the values that I'm interested in. You look at the document and you figure out how to extract the data, tie it back in here. And then this is the prompt with the instructions that I'm giving it, that I'm feeding into the API. By the way, one thing down here, if you are playing with the large language models, temperature 0. Does anyone know what that means? So the higher the temperature is, the more creative the model gets. If you're wanting to use data for business purposes, you want 0 creativity. Temperature 0. And so what you're telling it in essence is always go with whatever is the highest probable next step or next token. So the higher the temperature is, you'll start getting this range of tokens that it'll kind of alternate between. So temperature 0, this was something it took me a while to figure out. Like once I had it try to structure the JSON as a poem. I don't know where that came from. And so this is an example of what it comes back. So company, address, receipt number, transaction date. This one I love. So this receipt was sitting in the dash of my truck for about a year. So completely sun-bleached, almost completely illegible. It still extracted all of the data out of it. And the handwritten stuff, it actually did a decent job getting the data on that. Okay, so this is on the qualitative side. So kind of two different approaches you can take on this: the quantitative, the qualitative. So what a lot of this comes down to are what are the number of unique document types that you're dealing with. So if you've got 20 unique documents that you're dealing with and you're trying to ingest that data into JD Edwards, quantitative and data labeling is the way to go every time. Somebody spends a couple hours labeling the data on the invoice or whatever the document is, and maybe every 6 months the document type changes. They got to go back and tweak it again. That's the way to go. Dramatically lower cost, higher quality. But what if you're in a situation where you're literally dealing with hundreds of thousands, almost every data type that comes in is unique. So does anyone do expense management in JD Edwards or feed the data into JD Edwards? So one. So receipts. You're not going to data label on a receipt. Almost everything is going to be unique and special and different. So in this case, qualitative is absolutely the way to go. Use the large language model. Let it do the heavy lifting. But if you got 20, 30 vendors that you're dealing with, very limited data, the traditional quantitative model with data labeling is the way to go. Another thing that large language models are really good at is narrative. So taking the specific data and putting it in a form that you can represent to other humans, other non-accountants. So one of the things we've been playing around with is like financial reporting narratives. And I won't go through this one in detail, but the basic idea is that a lot of the work that you had an analyst do before, you can have the large language model do, but you still need the analyst. Now if you have multiple analysts, there's an opportunity possibly for some economic savings there, but you've got to have one. And the reason is, we don't 100% trust these answers. And you don't want to take some financial narrative, especially if you're a publicly traded company, and put this into your quarterly filings. You have to have this data vetted internally. And this is kind of probably the biggest takeaway with generative AI in embedding it into business processes, taking an agentic approach to it, is you still got to have a human in the loop. The quality of this is not sufficient to leave it running unsupervised. 3 years from now, this is going to be a completely different story. I mean, with the rate things are changing, 3 months from now, this may be a completely different story. But right now, you've got to have a human in that fire control loop. So, key takeaways. All of this that I was talking about today could really boil down to these two key points. So, use generative AI for qualitative in software engineering use cases. And by the way, I got into a debate with an older coworker earlier today. Does everyone know the word trad? Yeah, good. they're like, what does trad mean? I'm like, traditional. She's like, well, say traditional. And I'm like, no, all the hip kids say trad. and she said, I used to be hip, but now I'm hip. But use traditional analytics for your quantitative stuff. This is the area where you get in trouble, where you're not delivering the business value.